Good afternoon and welcome back to class with Edu. Thank you for joining us. Today we'll be talking about work, energy and power. Okay, today we will split it into work and energy. In the next class, next video, we'll consider power, so that there will be an understanding of work and energy, because work and energy leads to power. Today we are doing something on physics. So what is work? Work is defined as the product of a force and the distance in the direction of the force. Two things are important here. Two things are very, very important. It said there that work is a product of the force of a force and the distance in the direction of the force, or it is the product of the force acting on a body with respect to the distance in the direction of that force. What is that? Now note something. Our force, it is measured in newtons. You will see it, capital letter N written in front of your force. Like if you have force of 2, you have force of 2 newtons. And your S, which is the distance, some can write it as capital letter D or small letter d. And that is what? It is measured in meters. It could be measured in centimeters, it could be measured in millimeters, it could be measured in kilometers, but the standard unit is meters, small letter m. Can we move on? So when I say this, work done is from work. It is denoted by capital letter W, and that will be what? Force times the distance. And that means, what is our force before? Force itself is equal to the mass of the body times the acceleration on that body. So we can still write force as what? As mass times acceleration. Let's consider acceleration due to gravity. G is for due to gravity. Then we have times s, which is the distance. And that is why your work or work done can be measured in respect to what? The force times the distance covered by the body. Am I communicating at all? So that's what we're going to be having. But what if you have a situation like this? Let me note this. What if you have a situation such that you are having the force being inclined to a particular angle? Like you have a force acting on the body, and you have it, let's have something like this. You have something like this, and you have this place to be 60 degrees. You have this place, the force is acting, so the vertical is probably 6 newtons, and here is acting to the horizontal, probably 5 newtons. What do? You can calculate the resolution of this force. Yes, you can calculate the resolution of the two forces. If I indicate a broken line here, I have something like this. I have something like this. I can decide to calculate the resolution of these forces. Yes, you are doing something on that work. And what would that be? This place, this line, is equal to this line. And that to draw it this way, I'll call this the resolution of the force. And now would that be the resolution of the force, which is r squared from your Pythagoras theorem. That will be equal to what? 6 squared, then plus the 5 squared. So what do you have? You go with this, your r can be taken as the square root of 36 plus 25. So that will be the value of your resolution. But what if you're told to calculate the work done on this body as inclined to the vertical? What do you have? You will say your work done and be equal to the vertical. That will be F sine theta, where theta is our 60 degrees. To the horizontal, the work done to the horizontal will be F cos theta. Can you see that? That is the force, which is 5 newtons times cos 60. These are the situations you can have when you are solving questions on the work done. There are more situations. Okay, let me paint this as, I will use it as my example one. If I use this as my example one, I will say, okay, let me just draw something else again. I will not use the example one I have here. I will use another example one. If you are told you have a body, such that the body is inclined to a particular angle, not given, we give you theta here, theta, and the body is having 6 newtons here. 6 newtons. To the horizontal, it's having 10. We are being told it's having 10 newtons here. I think we calculate the work done by the body. What do you have? The work done will be equal. What do you do? Look at this place. Indicate a broken line here. Indicate a broken line here. Not giving theta. So this is a rectangular shape. So the work done will be equal to what? The length times the breadth. That means the length times breadth of the rectangle, which is what? Which will be equal to 6 times 10. And that will be equal to what? Be equal to 60 joules. 60 joules. So work is measured in joules, and you can have it if it's up to 1,000. You have it to be 1,000 joules to become a kilojoule. That's 1 kilojoule. So that's what we're going to be having if you're working with such a question. Now let's quickly solve our examples. Going by the examples, what do you have? You have the first question asking. You have this. Let me use this pen. You have this. A boy drags a bag of rice along a smooth horizontal floor with a force of 2 newtons applied at an angle of 60 degrees to the floor. The work done after a distance of 3 meters. What will be the work done? All you have to do is what? Go by what you have. The work done after that moment. It said a boy, let me see the question, confirm the question. A boy drags. Yes. So you have a boy drags a bag of rice along the smooth. Let me draw this. Drags a bag of rice. Let's assume this is going on along the smooth horizontal floor with a 2 newton force applied at an angle of, let's have 2 newton here. It's been applied at an angle, sorry, let me call this 60 degrees, so that this place will be 30. So 60 degrees. The work done after a distance of 3 meters. So the work done, like I said, illustrated initially, with a force times cos theta. Because you are given distance here, you have times your, what do I use to indicate distance? S. And that can be equal to what? Your 2 times cos 60. Let me write that, cos 60. Then times, they say the distance of 3 meters, so that will become what again? You have 2 times cos 60 equal to sin 30, and that will become half. So you have half times 3. This crosses this, and that will become what? 3. 1 times 3 is 3, and become 3 joules. That's the work done by the body. Let's go to example 2. By now, I expect we know what work it's all about. So you have that example 2. What is example 2 saying? Example 2 is saying that a constant force, please, in physics, in science, we jot down our data. We write down our data. I would not do that for the other question. I'm very sorry about that. So we have a constant force of 40 newtons acting on a particle initially at rest. Initially at rest. Under your knowledge of motion, that means u is 0. It just gives an acceleration of 0.1 meter per second. Our a is our acceleration, that is 0.1 meters per second square for 6 seconds. Time is 6 seconds. Now the question posted is calculate the work done by the body. The work done by the body. Work done is equal to what? Unknown. But we know that work is always what? Force times distance times time. And yes, force times your distance. Yes. And we know that this is equal to force times distance, S. Isn't it? Now, and this F also, were you giving distance? No. But our F itself is what? The mass. Oh, good. We're given force. Perfect. So what we need is our distance. Isn't it? But we know again from one of our equations of motion that what? We are given time. We are given that we know that distance itself, we can calculate it by using ut, initial velocity times time. That is ut plus, we have half, and you have a t squared. Another person can choose to go about this question in a different way, but this is one of the sure ways you can solve it. This will be 0. Initial velocity is 0. It was at rest, that will be 0. So you have times t. Let me clean this. Our t was given, though it's still going to result into 0 because of what we are dealing with. Our time is 6. Then plus, you have 1 upon 2 times, you have 0.1 times 6 squared. This one becomes 0, so this one will become 1 upon 2 times 0.1 times 36. Isn't it? I will 2 here 1, then 2 here 1, bring 1 here, that will be 18. So, pardon me, 0.1 times 18, that is just like 1 over 10 times 18. So that will be 1.8. So our distance is 1.8 meters. Now we can go to calculate our question. The question says what? Calculate the work done by the force. So the work done is now easy to solve. That will be the force times distance, and the force is 40 times 1.8, and that becomes what? I can write this as 4 times 10, then times 1.8. 10 times 1.8 will be 18, and that becomes what? 4 times 18. And what will that give us? 4 times 8 is 32. Right, 2, keep 3. 4 times 1, 4 plus the 3, that becomes 72. So 72 joules. That is the work done by the body. 72 joules. Now we go to the next aspect of what we are considering today. Energy. Energy is the capacity to do work. Now, so you have an energy, it is your ability to do work. Kinetic energy, okay, before I talk about kinetic energy, energy is also measured in joules. At times we use work done and energy the same way. You can see a body has a particular person has an energy, so that amounts to the work that can be done by that body. So if you have this, you are going to be having types of energy. You know, we have types of energy: the kinetic energy, the mechanical energy, light energy, the sound energy. We have a lot of types of energy. But under this topic, we're going to be considering mechanical energy. And under mechanical energy, we have kinetic energy and potential energy. What is kinetic energy? It is the energy possessed by a body in motion. When a body is in motion, it possesses a type of energy that is called kinetic energy. When a body is at rest, it also possesses a particular type of energy, and that's called potential energy. Like something latent is its potential energy. Now let's quickly go back to work and see what we can do about these two types of energy. This type of mechanical energy that we're going to be considering under energy. Energy, don't forget, I said energy also is measured in joules. The units you must know offhand. So we have that to be measured in joules, and we have some things to consider under that. Now, if we say kinetic energy is measured in joules and it is the energy possessed by a body by virtue of the motion it undergoes, what do we do? Kinetic energy is denoted by Ke. And what is that, please? The formula is 1 upon 2 half times the mass times the velocity, the square of velocity possessed by the body. Half times m times v square. Is half mv square. That's the formula for kinetic energy. While the potential energy is denoted by just the mass of that body, or solved by calculating the mass of the body to the product of the acceleration due to gravity, then times the product of what? The height or the distance covered, or the distance at which the body is placed. So let's solve an example under that. Both of them, don't forget, they are in joules. Example 4. A body of mass 4 kg. Let's write that out. The mass, the m, is equal to what? 4 kg. Is acted upon by a constant force. This is F. Constant force of 12 newtons. This one is mg. For we have the time, small t, or you can write small else, you have 3 seconds. The kinetic energy gained by the body at the end of the time is what our kinetic energy. So the kinetic energy gained by the body, Ke calculated KE, so we have what? Half times the mass, which you have, times what? The velocity, square the velocity. Or do you have velocity here? We do have velocity. So how do we go about our velocity? The velocity is not something hard to actually solve. It is not hard to solve. Since your F is equal to what? MA, and you have your M to be given in the question as what? So we have MA, and V is equal to the distance. Velocity, it is displacement with respect to time. So our F is MA, so from there we get our acceleration, because we have our M, we have our F. And having gotten that, also acceleration is what? Velocity with respect to time. And velocity because acceleration is time. So that settles the question. So if you are going and try to see the values we are using, let me check the calculator here. So if we have that sorted, let's see, what do we have? We have half times mv square, but we don't have v. But we need to get our v. How do we get? We know our f to be equal to m times acceleration. We have these two, so we have f is what? 12 divided by our mass which is 4, and that will be equal to our a, which is equal to 3, and that is 3 meters per second square. 3 meters per second square. Then we have this. Having gotten this, let's continue the calculation from here. Pardon me. Let's continue the calculation from here. So what do we have? We have this. We have this. So if you go on, our A is given now, but we know that what? Our acceleration itself is changing velocity, v minus u, with respect to time. And our v is already given, our u is 0. So what do we have? We have 3 to be equal to v over time. Our time is given as 3 seconds. So your v will be equal to 9 meters per second. So what do we do next? Now we can easily calculate our kinetic energy. So KE can now be equal to what? 1 divided by 2, that is half, times our M, which is 4, then times our V, which is 9 times 9, that is V squared. So 2 upon this, 1, 2 here, 2, and that becomes what? 2 times 81. Yes, and that becomes what? 2 times 1, 2, 2 times 8, we have 16, times 162 joules. 162 joules. That is what we have as the value to the kinetic energy possessed by the body. So the 162 joules, from there we'll take it up in the next class. So in the next video we're considering power. And power is the rate at which work is done. It is the rate at which energy is expended. So we consider that, since we know our work and energy, we know the power, then we are done. So power is not work done upon time, or energy upon time. It's as simple and straightforward as that. Thank you for watching. Thank you for watching. Quickly, you can help us, please, to subscribe. Keep subscribing to our channels. For more videos, we promise to serve you and give you the best of service. So in case you have any observation, anything to actually tell us, you can reach us. Reach me now on 081 64 8694 and add 70. Reach me for physical and online classes available, mathematics and physics. Then for any assistance, you can also reach us on that. For observations, you can reach us on that. For recommendations, you can reach us on that. Thank you very much. Till we meet again. Remain blessed.